Okay, pre-calc. So this video is going to give an overview of the first part of part 3. And then after that, I'm just going to talk about the notes that I took and explain kind of the process. So we start in part 3 with domain. And domain is basically what restrictions you have on x, if any. So number 1 is a polynomial. We talked about polynomials in the last lesson. And because it's a polynomial, there are no restrictions on x. For example, there's no square roots of x is not in the denominator, etc. So the domain is all real numbers, and I state that by going from negative infinity to infinity. If I want to use set builder notation, which is something you need to see, we say that it's all elements x such that x is an element of the real number system. So the bar here stands for such that. Okay, and then the set builder just means that I can plug in any real number for x. For number 2, I want you to think along the lines of, if I had the square root of x, I have to stay in the real number system. So that tells me that whatever's under the radical, which is x, has to stay positive or 0. So the domain for the square root of x is 0 to infinity. For x plus 2 under the radical, I would say that x plus 2 has to stay positive or 0. Subtract my 2 to the other side. X is greater than or equal to negative 2. So there's the interval, and here's the set builder. We say x such that x is greater than or equal to negative 2. For number 3, whenever you see a fraction, you need to consider the denominator. The only time you would need to consider the numerator is if you had, say, a square root or something like that in the numerator. So 2x minus 1, we know we can never divide by 0. So 2x minus 1 can't be 0. Add 1 over. X can't be 1/2. If I want to say that in set builder notation, I'm going to say, well, I'm at 1/2 on the number line. I can go left of it. I can go right of it, but I can't include it. So that becomes negative infinity to 1/2 union 1/2 to infinity. If I want set builder for that, I'm simply going to take, let me move that out of the way. I'm going to take my bracket, put an x, such that, close it off. So that's my set builder. And you really can't read that very well, so I'm going to rewrite it. Let me try that again. So set builder would be x such that x can't be 1/2. Now to see on number 4 what x can't equal, I'm going to set my my denominator equal to 0 or not equal to 0, I guess. We want to find out what it can't be. I'm going to factor that. And x can't be -5 or x can't be 2. So we want to ignore both of those on our number line. So we're going to go from negative infinity to -5. We can include all numbers in between those values. And then we can take 2 to infinity. Set builder would be x such that x can't equal 2 and -5. And then you have some practice problems there. Okay. I would imagine you're more familiar with what we did here on number 5. For simplifying a rational expression, we simply factored and divided common factors. You should back this up with x can't equal 6. For multiplying and dividing, factoring is the key step. So we factored the expressions and we divided out common factors. For number 7, when we went through the process, we saw that we had a x minus 2 and a 2 minus x. So to get those to be the same, we factored a negative 1 out of 2 minus x. That gives us x minus 2, and then we can cancel those out. For adding and subtracting, you're going to need a common denominator. So in class today, I talked about if you were adding 2/3 to 3/4, your least common denominator would be 12, which is 3 times 4. So it only makes sense that I'm going to multiply these two denominators together. And then we went through the process of getting a common numerator, getting the numerators fixed. So we looked at x plus 4 right here, and we compared it to x plus 4, x minus 1 down here. And we decided it needed x minus 1 right there to be the same. So we also included that in the numerator. Therefore, we multiplied by 1. We did the same thing on this side, but it needed x plus 4. For number 9, we looked at the problem like this. We decided, what if we had 2/3 plus 3/4 plus a 12th? Our least common denominator is 12. It's still 12. So if you look at it that way, x plus 1 times x minus 1 is x squared minus 1. So that can be our common denominator. And then we went from there. For your practice problems, you're describing the mistakes. So I would copy out these problems, and then I would annotate where the mistake or mistakes are. For number 10, there's a separate video that you can watch. It's already uploaded on Canvas. And here we are with the last bit, simplifications needed for calculus. So before we start on number 11, I had the class factor this expression up here, and they decided to factor out x to the 4th. They factored out the smaller power. So when you see something like 11, you can factor out the smaller power, which in this case is x to the negative 5/2. So the way I approached it with the class was we just had to fill in this blank right here. They filled it in with x to the 1st, because if we add 1 and negative 5/2, we'll be back to negative 3/2. Just like if you add 4 and 5 together here, you're going to be back to the 9 right there. So we just cleaned that up. We brought the exponent down to the bottom to make it positive. On number 12, I approached it a different way. I said you could also make your negative exponents positive, so we did that. And then we picked out the higher power for our common denominator. And then we took right here, in order to get x minus 1 to the 4/3 here, I had to multiply the red factor by x minus 1 to the 3/3, so that when I add them together, I get 4/3 right there. And whatever I do on the bottom, I do at the top. 3/3 is 1. And then I just cleaned it up from there. You could also do this problem by factoring. So I didn't finish this in class because we wanted to have time to take our quiz. But if I factor, I'm going to be taking out the lower power, which is negative 4/3. So I'm going to be doing x minus 1 to the 1st, because if I add 3/3 to negative 4/3, I'll have negative 1/3 left. And then I just have a minus x here. And then I can write the answer that way. All right, so I hope that clarifies some of the things in your notes. Reach out to me if you have any questions.